All right, so this video is focusing on perpendicular bisectors of a triangle and something called the circumcenter. The circumcenter is one of 4 different centers of a triangle. It seems weird, but yes, triangles have more than one center. A circle, well, it just has one center right in the middle. A triangle, though, there's lots of different ways of defining where the center should be, and the circumcenter is one of those. So to start off, I'm going to show you a construction I made of a triangle with all of the perpendicular bisectors constructed, all 3 of them, one from each side. All right, so I've got a triangle here, and I've constructed the 3 perpendicular bisectors, 1, 2, 3. Now, something interesting you might note is all 3 of those perpendicular bisectors happen to intersect at the same point. They all intersect right there. I'm going to call that point C. Now, one thing we shouldn't be surprised at is point C is the same distance from this endpoint and that endpoint because it's on that perpendicular bisector. It's also the same distance from this one and from that one because C is on this perpendicular bisector. And of course, this distance and this distances are the same because it's on this perpendicular bisector. So we've got this segment, and this segment are all the same length, which means if I were to take my compass and put one end on C and the other end right on that intersection point, it'll also hit this intersection point and that intersection point, which means I could make a circle centered at C that hits all 3 vertices of the triangle. That type of circle is called a circumscribed circle because circum means around, scribed means written. So it's a circle written around that triangle, hitting all 3 vertices of the triangle. That is actually considered to be a center of the triangle. It's a weird center because it's not even in the triangle, but that center is the center of the circle that hits all 3 vertices. It's the center of the circumscribed circle. As such, it's given a special name. That point is called the circumcenter. The center that is the center of the circumscribed circle. All right, back to the other screen. All right, so an important note, the perpendicular bisectors of a triangle intersect at a point called the circumcenter. You should know that. The circumcenter is the center of the circumcircle, which is a circle passing through all the vertices of the triangle. This is what we just talked about. It is important to note that the circumcenter can be inside of a triangle. It can be right on the triangle, or it can even be outside the triangle. You might suspect something about these triangles. Notice this type of triangle when the circumcenter is on the inside. This type of triangle when the circumcenter lands right on that edge. And this type of triangle when the circumcenter lands outside of that. Turns out there's a certain thing that's true about each of those triangles. Every time the circumcenter is inside the triangle, that triangle will be acute. If the circumcenter lands right on an edge, that triangle will be a right triangle. And if the circumcenter lands outside the triangle, this angle would be an obtuse angle, which would make that an obtuse triangle. All right. There is a vocab word called a word that we're going to work on with our vocab called the circumradius. The circumradius is just the radius of the circumscribed circle. So here I've got it says, what is the circumradius of this right triangle? Well, if it's a right triangle, again, I just learned from here, if it's a right triangle, I know that the circumcenter would land right on the edge there. And I know that would be the center of a circle that hits all the vertices. So I'm just going to sketch it to be this circle roughly. That's not a great sketch, but it'll work. But this is actually asking me, what is my radius of this circle? So the distance from here to that edge, or from here to this edge, or from here to that edge, because of course radii are all the same distance in a circle. So how long is that radius? Take a moment to see if you can figure it out. All right, that triangle we knew was a right triangle. One side was 3, one side was 4, so this is known as a 3, 4, 5 triangle. You could use Pythagorean theorem to find that that distance is 5. And since this cut that right in half, right? This is a radius on one side, that's a radius on the other side. So this and that are the same length. Each of those would have to be 2.5. So the circumradius for this particular triangle would have a length of 2.5. That is written as a theorem if you want. It says, note in a right triangle, the circumcenter is the midpoint of the hypotenuse, and the circumradius equals half the length of the hypotenuse. All it's saying is if you've got a right triangle, that circumcenter is going to land right there at the midpoint of the hypotenuse. One last part, it says, note 3 non-collinear points determine a circle. That is, there's exactly one circle that passes through all 3 points. So if you put any 3 points down, doesn't matter if you put them like that, or like that, or like that, right? However you want to put them down, as long as they aren't collinear, as long as they aren't in a line, those 3 points will determine a circle. One circle and only one circle will be able to hit all 3 of those points. To be able to construct that circle, I'll give you a hint. Instead, I would first construct the triangle that connects them. Because once you construct the triangle that connects them, you can find the circumcenter, right? Wherever that happens to be. I'm going to sketch it. And then you could use that circumcenter to make the circle that connects all the vertices of that triangle. And then that would be the circle that passes through each one of those points. Emphasize here, I just did a sketch of that. To do a construction, you would actually have to be a little bit more legit using just a compass and a straight edge. All right, that's the end for this video. Next video, we're going to be talking about angle bisectors and another center of the circle.